Hello everyone, on this part we have measures of dispersion. So on the previous part we worked on measures of central tendency, and here we have dispersion, and that is the degree to which the data are separate off. On this example, we have two data sets. One is from University A, the other one is University B, and for each one we have 100 students. And we compute the mean IQ score and also draw a histogram for each one. So this is for University A based on the data set we have here on top. And this is histogram for University B, which is based on that one. And so lower class limit is 55 and class width is 15. So here is lower class limit is 55 and 55 between the difference between these two numbers 55. Then after that we have 70. That's how we got our here class width is 15. So based on that, next part is 70. So 15 plus 55 plus 15 is 70. 70 plus 15 is 85. 85 plus 15 is 100. It's like that. So we have all these classes and the maximum number. So based on what maximum number is in each data set, here we choose to have that one for higher limit. So higher limit here is 160 because we want to have all these numbers in this interval starting from 55 up to 160. Okay. And we can enter all these data that we have for each university into our TI-84. I don't want to enter these right now, so I already did. And I got for University A, I got, since this is sample, we're gonna use X bar for mean. It's equal to 100. What we have here for University B, based on these numbers, sample mean is again 100. So we have the same sample mean, and also finding what standard deviation is. Standard deviation was 16. We're gonna cover this part later. For now, just I wanna just write this information that I got from calculator. So 16.1, and here standard deviation is equal to 8.4. So we covered what the steps was for this part, finding mean from previous section. So exactly same thing, use a stat, then enter your data in the first column. So all these should be in one column. And then again, press stat, calculate, choose the first one which was var stat. Choosing that one and then enter, you'll be able to see your result. We're gonna work on more examples later. For now, let's write what the standard deviation is, writing that part here. So standard deviation is a measure of the amount of variation or dispersion. So here we work on dispersion, that's why I used that standard deviation to find it and compare these two universities. So this one is measure amount of variation or dispersion. of a set of values. Or we can say standard deviation I'm going to use ASD. This is for standard deviation. That is the measure of how separate of the numbers are in a sample. Here, these for University A and University B, these are samples because we have 100 students, and this number is not all the students that we have for each university. So that is sample. A measure of how separate of the numbers are in a sample. So based on the definition that we had here, that this standard deviation measuring the variation or dispersion, here on this part, comparing these two, standard deviation for University A as this number is larger than what we have for University B. What that means on this part we have more dispersion. So more dispersion, and here we have less. So this one we have higher standard deviation. And also we set that mean as 100, so this one here is mean. Same thing for this part, that is mean. And as you can see, our numbers for this part, starting from okay, here we have 55 and here we have 145. But for this one we have starting from 85 up to 130. So on this part range is from IQ scores of 55 to 145. This part ranges from IQ of 85, so that is 85. So IQ score of 85 to 103, which is that one. Okay, next page. Now, this part we should determine the range of a variable. How are we gonna find that? And so, range of a variable is the difference between the largest and smallest data value. So, finding the difference between these two, showing with R, largest data value minus smallest data value, that is the answer for range. Example number 1, the following data represent the travel times in minutes to work for all 7 employees. Here we have all 7 employees. If you remember, we had exactly this one in previous section, was example number 3, part A. And I said that part, since we worked on median, it doesn't matter if you know what the sample, if that example is sample or population, it doesn't matter because you're working on median. But here, we're gonna work so after this we're gonna work on mean, standard deviation. So let's find out what that is. Since we have all, that means that that is population. I think I mentioned that one also in previous section, that since we have all, that is population, but we're not going to use that. So these are our data. To find a range, we should rearrange these, or it doesn't matter if you just find which one is the smallest number and which one is the largest one, and find range. So max is 43, smallest one or minimum is 5. Now range is maximum minus minimum. So it's 43 minus 5. That's equal to 38. So this is our range. So this is maximum value and this one is minimum. Okay, now the next part we should find standard deviation of a variable. First part, this is a population standard deviation, and we call that sigma. The population standard deviation of a variable is the square root, so the square root of the sum of squared deviations above the population mean. So that is about population mean. And when you work on sample standard deviation, that is about the sample mean, not population mean. So on this part, focus on population divided by the number of, so here we divided by number of observations in the population, or that is population size. So this one is population size, and these x1, x2, up to xn, these are data value. So all of these. These x's are data value. And this mu is population mean. So all these mu are population mean. Okay, so this one describes how far on average each observation is from the typical value. So here we have the difference between n. Since we divided by n, that's why that is the average. So how far on average divided by n, each observation, which is all x's, is from typical value. So finding the difference between data value and our mean divided by population size. So these x's are our data value, and n is observation or population size, mu is population mean. Okay, now example number 2, the following data represent the 12 times. Again, we have this one to work for all 7 employees. So this part is population. Net sample, and we have these data. Compute the population standard deviation of these data. So of this data, I'm going to use TI-84. I suggest you to use TI-84 instead of a StatCrunch, because on StatCrunch you may see sometimes sample standard deviation instead of population standard deviation, and it may confuse you. So now using TI-84, so press that. Press that, we have this word. You should have this page, and after that, here is edit, enter. Then enter your data in the first column, L1. We have these. Then after you entered again, press that. So again, I have this page. Now you should use this calculation part, calculate, and instead of edit, so choose that one. Now we have this. So the first one is var stat. Choosing that, enter. This is what you should have. Since we have one column that is L1, you shouldn't have L2. So L1, enter, enter, again enter. This is what we got on TI-84. If you scroll down, you're going to see what median is. Median is 23. So for now, I need this part. Our mean is 24.857. And as said, this one is population. So when you're writing it, I'm not going to write as X bar. Instead, I'm going to write mu. When you enter data, this calculator, it doesn't know that your data was based on population or sample. That's why you may see X bar instead of mu. But you already know that you're working on population. Since you're working on population, what standard deviation is, this is standard deviation for population, and this one is standard deviation for sample size, starting with S for sample, and the sigma is for population. So the answer for standard deviation, population standard deviation is 11.3569. If we round it, will be 11.36. Okay, now let's find the answer without using calculator, but I need to have that part to find standard deviation. So I'm using this 24.857. Here on this part, we need to know what mu or mean is. Mean is 24.857, and we used TI-84. Now finding population standard deviation. Okay, so that is equal to, here we have x1 is 23, minus mean is 24.857, square, then we have plus. Now the second data value is 36, again minus our mean 24.857 square, plus the third one is 23, minus again mean. So continue all these for all these 7 data. Phi minus and finally 43. And divide by n, which is number of observations or population size. So n is, how many numbers we have here is 7. Okay, so that is equal to this part. First subtract 23 minus 24.857, and then square that is 3.448, plus here we have 124.166, mm, 3.448, 47.018, plus 394.300, or you can write 0.3. Since I used 3 decimal, that's why I have 300 here. Plus 1.306, plus 329.168. Divide by population size is 7. Okay, so that is equal to adding all these numbers on top is 902.854 divided by 7. So divide and then use the square root. So first I'm dividing it and round the output. Here I got 128.979. Okay, round that, the answer is 11.36, which is exactly what we got using calculator. So this is without using calculator to find population standard deviation. Okay, next part. Now here is a sample standard deviation. The only difference here is that instead of dividing by population size, we will divide by sample size minus 1. And that is because we have n minus 1 degrees of freedom in the computation of standard deviation, because we have unknown parameter mu that is estimated with x bar. For each parameter estimated, we lose 1 degree of freedom. Okay, so that part may seem a little bit complicated, but you only need to remember that when you have a population, you only need to divide by population size, so that is n. But when you have sample standard deviation, because of that degree of freedom, so because we have 1 degree of freedom for each one that we lose, for each parameter, we're gonna subtract 1. So subtract 1 from sample size. This n is sample size. Here is sample standard deviation. Sample standard deviation. These x's again are data value. And this x bar is mean. So that is mean. Here is mean. Mean. Exactly same thing. Find the difference between mean and data value. Divide by sample size minus 1. So that is the only difference we have. Okay, now example number 3. Here are the results of random sample taken from the travel times. So these data are from this part. So the population was this one, 23, 36, 23, 18, 5, 26, and 43. So from those, we selected 3 numbers, and those 3 numbers are 5, 26, 36. So 5, 26, and 36. So all these 3 numbers are in that population. But that means this one is sample. So here are the results of random sample. Finding standard deviation. Now instead of sigma we have S. sample standard deviation is equal to here n is equal to 3. This is sample size. So divide by 3 minus 1. And our data values are 5, 26, and 36. So 5 minus. Okay, first we need to know what mean is. Need X bar. Using calculator, we got 22.333. This is using TI-84. So exactly same steps as that. Edit, enter data in first column. Again, stat, choose calculate, and the first one var stat, enter, you're gonna get the answer for X bar. Here, instead of mu that I had here on top, this one was for population, that's why I used mu, but here is sample, so I'm using X bar. So 5 minus this number, 22.333 square. 26 minus 22.333 square plus the third one here is 36 minus or minus 22 point. Okay, square that. So that is equal to subtract, square, adding all these numbers. Okay, I'm gonna write first each one and then add. This part is 300.433 plus 13.447 plus 186.787 divided by 2, because we have 3 minus 1, sample size minus 1. That is equal to, on top, adding all these three, we have 500.667 divided by 2. Okay, rounding, the answer is 15.82. And it's in minutes. This is sample standard deviation. Okay, next page. On this part, just showing us which one is population standard deviation, which one is sample standard deviation when you use TI 8384. So this one here, sigma is population standard deviation, and here S, that one starting with S, so we have that is for sample standard deviation. Now here we should find variance. Variance of a variable is the square of the standard deviation. So whatever your standard deviation is, squaring that is your variance. The population variance is sigma squared, and the sample variance is S squared. So this is population variance, and this one is sample variance. Okay, so here example number 4, we have exactly same data. Again, we have all 7 employees. We already know that this was population because we have all 7. Compute the population and sample variance of these of this workers. Okay, here for sample, I'm going to use what we had here on this workers. We already had sample from that population was 5, 26, 36. So what that means, we're going to use all these information that we got from example number 2 and example number 3, finding variance for example number 4. So first, population. We should find, we already have standard deviation. Squaring that is the answer for this part. So the standard deviation is equal to, here we have population solution with sigma. That was equal to, I'm going to use what exactly I got on calculator, not what I rounded, so 11.356, because on the previous example we rounded to have 11.36, but here I'm not rounding it. It's 91824. Now finding variance, which is equal to square standard deviation. So 11 point, exactly this number here on top, squaring that. That is equal to 128.98. And that one is in minutes. And here I rounded this one, because we on calculator got 128.9795. So I rounded to have 0.98. Since I rounded, let's use this symbol. Okay, now we're gonna work on sample. And for sample, standard deviation was 15.82. I'm going to use that one. Standard deviation for this part, since this one is sample, use S. And we got 15.82. Actually, we rounded this part. So, but if you write equal to, that's fine. So variance is So that is equal to 250.2724. I'm using 250.27. So this is in minutes. So that is in minutes. And that's the final answer for that part. So let's add what numbers are used here, because you may say later you may say, okay, where is the example? So example was from previous example is 5, 26, 36. Next page. Now in this part we have a empirical rule to describe data that are bell-shaped. Remember on the first page that we covered, we had two universities. Here, okay, on this part, we have a histogram for these two, and this one, histogram for University A. This is the highest frequency that we have. That is in middle, so this is bell-shaped. And this part empirical rule is to describe data that are bell-shaped. Here we have the distribution. So if a distribution is roughly bell-shaped, then we have approximately 68% of the data will lie within one standard deviation of the mean. So what that is. Here we have this mean is in between on this part. And what we have, this part is 68% is within one standard deviation. Then after that, we have 95% is within two standard deviation. Here is 99.7% of the data are within three standard deviation. So that is 99.7%. Where that 0.3% is. 0.15% is here on left side, and the rest of that is on right side is 0.15%. So adding these two, 0.15% plus 0.15% is 0.30%, plus that one, 99.7%. In total, you're gonna have 100%. So let's write that here. So that is 99.7% of data values that are within three standard deviation. So 99.7% plus on the side we have 0.15% plus here on right side is 0.15%. In total is 100%, and that is what the area is for this distribution. So in total, area is 100%. This is exactly what we did on the previous section. Said that if you add the frequencies, you're going to get that part equal to 1. What that one was 100%. Exactly what we have here is area or probability or proportion. So all these are same thing. Equal to 100%. And why we say is one standard deviation, because here we have 1. So mean minus 1 times standard deviation, so it's 1 standard deviation. Here also is 1 standard deviation. On this part there's 2 times, so it's 2 standard deviation. Same thing for this part is 2, so it's 2 standard deviation. Here is 3, here also is 3. So this part data are within 3 standard deviations. We have all these here again. Once again, 68% is within 1 standard deviation, 95% is within 2 standard deviations, 99.7 within 3 standard deviations of the mean. So it's 3 standard deviation of the mean. That's why we're subtracting, finding the difference between mean and 3 standard deviation. Or in other words, it's better to say 3 standard deviation of the mean. So our data lies within this interval as mu minus 1 standard deviation and mu plus 1 standard deviation. And for this part, we have mu minus 2 standard deviation plus and mu plus 2 standard deviation. And third one is between these two. It's mu minus 3 standard deviation and mu plus 3 standard deviation. Okay, now example, use the data from University A. Why University A? Because I said we're going to use this one for a bell shape, and University A, the histogram for that was bell shape, not B. So for University B, we didn't have bell shape. Yeah. So first, fill in the chart. I want to find what we have here for all these. What that means is what we have within 1 standard deviation, 2 standard deviation, 3 standard deviation, what data we have. So first, fill in the chart. Recall that we had from first page, export was 100 for University A, and sample standard deviation was equal to 16.1, and our histogram was bell-shaped. So we had all this information from the first page. Okay, so in between we have X-bar. I'm not writing mu because this one is sample. The X-bar is 100 on that one. Now this is within 1 standard deviation. X-bar plus 1 standard deviation. Here X-bar minus 1 standard deviation. Here is X-bar plus 2 standard deviation. This one is X-bar minus 2 standard deviation. See what the difference is between this one and the previous page we have here. Here, since this is for population, instead of X-bar we have mu, instead of S we have sigma for population standard deviation. But here we have sample standard deviation, that's why we have S. And finally, this is X-bar plus 3 standard deviation. On left side, X-bar minus 3 standard deviation. Okay, so let's find the answer for each one. So this was 100. Here is 100 plus 1 times 16.1, so it's 16.1. So that is 116.1. Now here is 100 plus 2 times 16.1. That is equal to 132.2. Okay, let's do the same thing here. So this is 100 minus 16.1. That is 83.9. And here 100 minus 2 times 16.1. It's equal to 67.8. And within 3 standard deviation, we have 100 plus 3 times 16.1, and that is equal to 148.3. Left side, 100 minus 3 times 16.1, it's equal to 51.7. Okay, so we got all these. Numbers, that one. Now, based on what we have here, we can answer these questions. Part A, determine the percentage of students who have IQ scores within 3 standard deviations. So this is within 3 standard deviations of the mean. According to empirical rule, which is this one. So what we have within 3 standard deviation, that is percentage. Percentage will not differ based on what the data you have. It's always equal to 99.7%. So regardless what your data are for these part that we got here, the answer is always 99.7%. Data are within 3 standard deviation of the mean. The answer for part A is 99.7%. So based on empirical rule, we can say approximately 99.7% of the students are within 3 standard deviation. Okay, so that is the standard deviations. Part B, determine the percentage of students who have IQ scores between, now we have between these two numbers, 67.8, 132.2. So we need to use these. Finding these two numbers on top. One is here, 67.8 is that one. And the other one, 132.2 is this part. Now based on that, we can see that these two are within 2 standard deviation. And what the percentage is for that part is not changing. So always you have 34%, 34%. Here is 13.5, 13.5. Here is 2.35, 2.35. So these numbers will not change at all. When it's within 2 standard deviation, if you forgot what that percentage was, you can add all these 4 numbers. So that is equal to 95%. See, here within 2 standard deviation, we always have 95%. Make sure to remember all these 3 numbers. These are important. So you need to know what those percentage are. So the answer is 95% for this part. So 95% lie between these 2 numbers. So this is the final answer for part B. Now part C, determine the actual percentage of students who have IQ scores between these 2 numbers. Here we got 95%. This was based on empirical rule, but here asking to determine actual percentage. We should use our data from the first page for University A. Okay, so this is what we have. And part C was that you should have scores between 67.8 and 132.2. We have many numbers here. So instead, I want to see what numbers are not between these two. So the numbers that are not between 67.8 and 132.2, those are 136. We have 62, 141, and 60. So these 4 numbers are not between those 2 numbers that are given. Let's use those here to find the answer for part C. So using that table we have on the first page for University A, the 100 scores. Only 4 are not between. (67.8) and 132.2. And what were those numbers? We had these 4, 141, 136, 62, and 60. So these numbers were not in this interval. Therefore, 96. So in total we have 100 scores, but these 4 are not inside that interval. So that means we have 96 scores in this interval. Therefore, the percentage for this part will be 96% because we have 96 scores between these two. 96 out of 100 are between. Or what that means is that the answer is 96%. You may say, okay, well, we have 95 here and 96%. That's fine because this 96% is very close to 95%. And this is what the actual percentage is because we had our data in that table. So very close to 95%. And the answer is this one for part C. Part D, according to empirical rule, what percentage of students have IQ scores above 132.2? Here is 132.2, and higher than that, we have this part is so we should consider this part here to this point. So here we have 2.35% plus 0.15%. That is the answer for this part. So these two are higher than what we have for this part. So scores higher than 132.2 are in this area. So that is approximately 2.35% plus 0.15%. That is equal to 2.5%. So 2.5% will have IQ scores above 132.2. So the answer for this part is 2.5%. Okay, we finished this part.